Hello everyone, this is Maurizio, Editor-in-Chief of Power Electronics News, Aspen Core Media Publication, and I am here at PCIM showing Nuremberg, and I have the pleasure to be here at the Infineon booth with Gerald Deboy, fellow at Infineon Technologies. Hi Gerald, thank you for being here, thanks for your time. How's it going?
Hi Maurizio, thanks for having me. It's my pleasure to explain what Infineon is doing in order to cover the entire storyline powering AI from grid to core.
We are at PCIM, so my first question is what's new from Infineon?
AI is currently the booming application. We are seeing a lot of increase in power on all levels. We see much bigger data centers. We are seeing much higher power levels per rack, and we are seeing a tremendous increase in electricity consumption on all of the fronts. So AI is a place to be. This is where power electronics excels in a lot of different applications.
Thank you. So let me share my first comment, my first question for you. So we are seeing AI data centers, as you mentioned, AI data centers push past the 1 megawatt threshold per rack. So how is this influencing the design, the architectural design of power system when we are talking from the grid interface to the component processor level?
What we are seeing for large training of AI models is to cluster hundreds of thousands of GPUs into one virtual machine. Mm-hmm. And because of such large clusters, it's in the first place very important to scale up within the rack, so pushing as many GPUs as possible within one rack. That is what is pushing the power envelope. We are seeing a transition in a couple of steps. We are expecting around 600 kilowatt of rack power, 4 times what we see today, in around 2 years. And we are expecting power racks with more than 1 megawatt in 3 to 4 years to come. That is a tremendous change. We need to upgrade the power delivery system. We can no longer cope with 48 volts distribution system. We clearly need to go into high voltage DC distribution out of the sheer level of power and sheer level of distribution currents.
So another topic, AI, okay, another topic is high voltage DC distribution. So this is coming as a new standard, if I would say new standard. So what are the safety control, interoperability challenges that come with it when we are moving from low voltage to high voltage DC distribution?
So currently, following the announcements of major players in the AI industry, we are expecting either plus and minus 400 volt or 0 and 800 volt. And of course, every equipment which is plugged into a high voltage DC distribution line needs a couple of hot plug functions. So we talk about pre-charging the input capacitors of, for example, a motherboard now running on high voltage DC. We also need an O-ring function. When you pull out a motherboard, you need to discharge the capacitors in order to avoid any human hazard. So basically, every equipment which is plugged into high voltage DC distribution is having 3 distinct functions: an E-fuse, an O-ring, and a discharge function. Power electronics everywhere.
I agree, power electronics is everywhere. So vertical power delivery to GPUs and AI processors is gaining interest, gaining traction. So what are your considerations? What are the main design considerations for power stages at the package board level to support such dense vertical integration indeed?
So in order to increase the compute capability of GPUs, there's only one way: making the GPUs larger and going to even smaller process nodes. So we are seeing 2 major trends. On the one hand side, ever bigger chips, limited by the maximum reticle size of the steppers, 2x today, in future up to 4x, so the chips become larger. At the same time, the supply voltage of the GPUs goes down from 0.7 volt towards 0.4 volt. And as the power levels are increasing due to the larger chip size, we talk about a massive increase in load currents from the 1000 to 2000 ampere range, which we are seeing today, towards the end of the decade, up to 10,000 ampere. At a power level or current level of 10,000 ampere, lateral power distribution in no way can cope with the challenges. Therefore, we need to go in the shortest possible distance. We need to bring power to the backside of the GPU and power the chip from below directly up.
So thank you, Gerald. In conclusion, my last one, which is your key message, which is your one piece of advice for the next designers when they are moving to the next gen AI data centers?
Yeah. So as mentioned, power electronics is everywhere. So being now in power electronics is exactly being at the right spot. There is lots of chances, lots of opportunities. Infineon is shaping the transition from the 48-volt ecosystem into future high-voltage distribution. We are launching products along the entire power conversion chain from grid down to core, and especially on the topic of vertical power delivery, we have been launching now a new 4-phase integrated module called Cavalry, which is a 4-phase point of load power stage in the classic 9 by 10 millimeter footprint.
Thank you for your time, Gerald, and have a good show at PCIM. Thank you.
My pleasure. Thank you.